Hey everybody, my name is Zach Pike. This is my final project for CSC 436 offensive network security. Um, uh, Picking a tool that we didn't really discuss in class or we didn't go over. The tool that I picked is called BloodHound. It's a tool that I'm familiar with that I've used in my professional life and professional work. I'm somewhat familiar with it. It's a really cool tool. We didn't go through it. It has benefits for kind of um, an offensive minded security, and it has benefits for blue team network security that also wants to use it in that way. So, final project, Bloodhound. So, what it is and what it's for. Bloodhound is a tool that can run on a network, and typically the most value from it, in my experience, and kind of anything I've ever read about it, is that it is most valuable in a network environment, um, in an Active Directory environment, especially. Um, but it's a Java-based web app that kind of just it runs through a web interface. It sits on top of a Java-based applet, kind of Node.js. You have to have some prerequisite installs, Node.js being one of them. It's Though it's a web app, it's not for web app security. It is run on Java, so if it were web app security, they probably wouldn't use Java. But Bloodhound uses graph theory to uh, explore a network, an active directory network, to enumerate users and groups and permissions and control lists and all these different aspects, all these different features that Active Directory provides. Bloodhound explores them, and it uses graph theory to put them in an order, in a connected order, to give you kind of a graphical representation of what your network looks like and how it can be traversed. Um, it shows the relationships between user accounts, between Active Directory objects, between sessions, between permissions. Um, it can show you access control lists. It can go so far as specific functions, domain controllers, and then you can be creative to find privilege escalation paths, which is where your offensive network security is really going to happen with Bloodhound. Who uses Bloodhound? Like I've already mentioned a little bit. Most people that are going to use it's going to be most beneficial in a large or enterprise environment, because you're going to have domain controllers and you're going to have Active Directory, you're going to have user groups, you're going to have ACLs, you're going to have all of these things. For a small, like a home environment or a very small target, it's not going to be a useful tool. This is a big target tool, which has other implications, and we'll kind of get into those as we go along. Um, it's useful to red and blue team, and by that I mean that the red team implication is pretty obvious. If you can get this on a network, if you can get Bloodhound installed on a network, and you can run it, if you can do that, you're that skilled, or you have that kind of access. I'm sure that Bloodhound is going to return a lot of useful information to you about how you can get very, very high privileged accounts to do all sorts of things. That in mind, Blue Team uses it, and this is my experience with it. Working in security, Blue Team can use this to run on your own network to create awareness amongst IT and the different teams, to kind of show what your Active Directory looks like, to show these accounts that are out there that that have all this access and can be exploited and can be moved across laterally and can be escalated. You can show that. You can put that in a PowerPoint to a board or to stakeholders and say, hey, this is real stuff. Look at, all you need to do is access this one very basic user account and step, and you hold the keys. So it gives you some great, very visual things to use to create awareness and kind of get your point across as a blue team defensive person. Why it matters? Well, because you don't want people that aren't you doing this to your stuff. You don't want people enumerating users and devices and privileges and controls and all of the other things that we've talked about already. It also matters because it's everything. Your AD in your organization, with maybe the exception of a few very local things, it's probably very integrated. There's LDAP and Kerberos and all these other authentication methods that are touching Active Directory. And when you have that enumerated, especially when as it relates to that account's privilege level, it's floodgates. You can go crazy with that because you know where everything is and you know who can do what and where. Lastly, another reason it matters is a lot of malware. If you're familiar with NotPetya last year, it's a really good example of this point. Malware contains lateral movement components. NotPetya had a Mimikatz element that used in conjunction with PowerShell and Eternal Blue. It had a few different lateral movement components, but it would try to enumerate users and it would try to move laterally in your environment. I'm using Eternal Blue first, and if it couldn't do that, you had SMB turned off or firewalling on 445, those kinds of things. It would then use Mimikatz to steal local credentials, to harvest them, and then PowerShell with WMI to move across your network, reaching out to anything that it could contact, looking for privilege escalation. And PC to PC, server to server, when it found a new, more privileged account, it would harvest those credentials and then it would use those to move to the next. BloodHound can kind of do that for you in a safer way and allow you to move across your own network and see what that looks like. It's available on GitHub. There's, like I said, you can run it. I'm running it on a Mac. I've run it on Windows and Linux. Like I said, it requires Node.js and Java to be installed. A graph data database, that's going to be the things that creates those graphs and that graphical representation for you. And a data collection point, depending on your environment, could be big and sizable, so space is a consideration there. Uses a web interface. This is where your collections are configured and launched. Now I'm going to do a quick walkthrough, and this is going to be underwhelming because I am on my home network and it's not an Active Directory network. There's no domain controllers. There's no larger access control lists, things like that. I'm just going to kind of show you what it looks like and where the options are found. After that, I have some pictures from results from my organization, which is a very large organization, tens of thousands of users, large Active Directory environment that we ran BloodHound on. And I think that is a really cool, really useful thing to show. It was eye-opening for all of us in security and as well as IT career professionals. So it's cool to run things locally, but it's a whole other deal when I got to see it on such a scale. So what you'll see here is the startup and mapping options and configurations, and just kind of launching BloodHound. It will fail, spoiler alert, but like I said, that's really not the interesting part here. So here we go. Just kind of a, hey, great, thumbs up for me. I've got to do this in a big way before and be involved in that, and that's exciting. And hopefully you'll find that interesting as well. And the following slides are real data. So before we get to this, or before this makes any sense, let's look at the tool itself. A big white screen, kind of boring looking at face value. And we'll start a step further back. So the first thing you have to do is you have to have a Neo4j installed. It's kind of a Java-based program that allows you to kind of create the database configurations and relationship to run with BloodHound, which is also installed. Just kind of it's hosted. You can pull it down from GitHub. It's just a bloodhound.exe. It's already packaged for you. There's not a ton of work to do there. But before you do that, you do have to have Neo4j installed and get your database and collection points in the right place, which you see here. It's running, and you can see that I'm connected. My local host on this port. My connection. This is where it failed initially, but this is the one that is up and working and running. Everything's good there. So then I come here and I would launch my BloodHound application here. It will open. It'll prompt you for username, password. You'll get into the tool. It'll look like this. It's essentially nothing here. Just kind of a refresh option, export, import. If you want to import a graph so you can manipulate it, you can do that here. If you want to upload data to put into a graph, you can do it here. If you found information in some other way and you want BloodHound to kind of use it to graph, you can do that. Some layout options, kind of where stuff's located. It's mostly appearance-based. Settings, some debug stuff. I'll make it dark mode hackery if you want. Some labels, some organization stuff. Node collapse threshold is just how, if there's nodes behind nodes, just kind of how it'll help you keep things organized based on how busy and how big your target is. Information about BloodHound. You see what happened here, where you get it. People that set this thing up. I guess you can follow them on Twitter also if you'd like. So up here is where you're really, if you type for a name, if a PC name like Zach PC1, and then you can put a host here, and then you can just click go over here if you want it. Like I said, it will fail. Over here, you can create, this is where you can really get granular and you can really whittle things down, and that'll make more sense in this next part here. So, the privilege-based, container-based, OU-based, distinguished name-based, access control, permissions-based, if you can add members, and what rights are extended, and sessions and admin too are going to be really important. And I'll show you that here. And that's kind of the tool. The tool's basic. Really what it is a lot of trial and error on a network to see what you can return, and with these options. The options are limited, but when you get in a big environment, you can get very creative with just a few options. So you can see here, this is our graph imagery from just kind of an all-out everything on scan. So many lines, so many nodes, so much everything itself. Obfuscation occurred. It's not worth anything. So you got to narrow it down. So here we go. We look for active users, which are your green on the right. Active users with active sessions to domain computers of a certain role. I've taken everything out of this because it is a real company with real users with real things, so you can't know what those are. But that you would have over here, you would have your username, and over here you would have a device name, fully qualified device name, so you can see what Active Directory users and devices are. Here again, the quality is not wonderful because I had to take all that stuff out, but you can see as we work left to right, this has admin privileges over, permissions to, or an open session with. So everything on the left, moving left to right, all the way to a desired admin role. So you can see that you could start, if you got initial access over here, you could work all the way to your specific admin target on the right. And here's another one. This is a graph where it will show you a path to a certain level of admin. King of the castle. It will show you, with BloodHound, you can not only find the users, find the permissions, but you can also, it's kind of hard to see here, but you can see what permissions are needed to kind of exploit that next level. Like here, it's a member of this group. You add them as a member of that group. You can get here. You can force a password change to steal this next account on down the line all the way until you're king of the castle. So kind of in conclusion, I've run a little long here, but in conclusion, scans, the scan lets you jump to conclusions. You can use your imagination to come up with a scan, and based on those conclusions, if you're an attacker, go wild, attack anything you can, escalate privileges, get into the network, get into whatever you want, get to a domain controller and own everything. Or we found more use in it defensively, because then you get to dream up what attackers might do, and then you can start fixing and remediating some of these issues. You can create some behavior-based analytics if you're using a SIM, and create some alerts. Splunk is great for that kind of thing. You can get rid of some permissions that you might not have known were sitting around that could be used maliciously. Or if you have deprecated protocols, SMB v1 and things like that are out, you can turn those off. Turn that service off in Windows. You can turn the ports off. You can firewall things. You can segment things. You can do all of that. But yeah, you can really run wild with the information you get from BloodHound. Again, sorry for the image quality. I just think it was cool. It's cooler to show that how in a bigger environment than it is in just showing how the actual tool works, even though it would fail. A few references if you want to go and download it or read about graph theory. And that's all I have. I hope you learned something and enjoyed. Thanks. Bye.